Welcome everyone. In this video, we're going to work out another optimization problem. So let's take a look at this particular example I have here. The US Postal Service will accept a box for domestic shipment only if the sum of its length and grid, which is the distance around it, so that's this right here, does not exceed 108 inch. What dimension will give a box with square end the largest possible volume? Well, what this means is we want to maximize the volume function. So the volume is length times width times height for a box, rectangular box, let's suppose. Now we want this end to be a square. So that means this side, if I call this x, then this is also x, and then this is also x, this is also x. So you can imagine that you're compiling up squares right here. So imagine there's a square that's creating this box of length L. So let's call that L. Now, if I let x2 stand for the dimension of from the bottom, and which is a square, and you're compiling up all the squares to see how large the box has to be so that we can find the largest volume possible. So that means that the length of the grid, it's going to be, so the grid is this right here, all of this around it. As you can see it there in the blue, grid is the distance around it, so I'm calling it x. So I have 4 sides, it's going to be 4x. So we know the length of the grid and sum of its length, so which is L I'm using, cannot exceed 108. So we can say that 108 is equal to 4x plus this length right here. So that's one of the equation. Now if I isolate, let's say L for instance, then I get 108 minus 4x. So that's one of the equation we can use as a helping equation to optimize the volume function. So for this box, we see that the length is x, the big L, and the width is also x because we're making a square in one of the end and then just compiling up those squares. So that means for the volume equation, we can say that this is equal to x times x, and the height, which is determined by, in this case, let's make it face this way, so that's going to be L. You can keep it as height, but then you would have to modify this as well. So I'm going to call it L. So then this is equal to what? So the volume, if you rewrite, it's going to be x squared times L. Well, what is L in terms of x? Well, L is right here. So let's plug this in here so that you can express everything in terms of x. So your V is equal to x squared times 108 minus 4x. And then by distributing x squared out, you have your volume function, which is equal to 108 x squared minus 4x cubed. All right, so now we want to find its critical number and see if that will give us the maximum volume. So let's go ahead and take its derivative. So V prime is equal to, using the power rule, 108 times 2, that's 216x, minus 4 times 3, that's going to be 12x squared. And then we set this to 0 to find the critical number. Let's go ahead and factor out a 12x. So then 12x times 18, that's 216x minus x is equal to 0. All right, so then if you set them to 0, you got x equals to 0 and x equals to 18 inch. But of course, we don't want to use x equals 0 because having length equals 0 doesn't make sense. It means this is the only critical number we have. Now, will this provide the maximum volume? Well, let's check the second derivative function. So if you take the second derivative, so here's v prime, take the second derivative, you will get 216 minus 12 times 2, that's 24x. And now when you plug in double prime, v double prime of 18, you'll get 216 minus 24 times 18. And that's a negative number, which means this is concave down. Concave down means we get the maximum volume at this, we have a local max right here. So that means we do have a maximum volume of this postal box when x is equal to 18. So that's how the dimension has to be. So we know that if x is equal to 18 inch, then the length has to be what? The length has to be, so right here, we see that L is this formula. We were able to solve for it beginning of this problem. So I'm just going to put that right here. So we know L is equal to that. So I'm just going to put it right there. So if L is equal to that, plug in 18 into x. So 108 minus 4 times 18, and that would give you about 108 minus 72, which is 36. Let's call it inches. So if the dimensions are, so the square end has to be 18 by 18, and the length is 18. That will be the box that will, with this dimension, will have the maximum volume. All right, so I hope this makes sense.